Hi, Dr. Ron England here. We're continuing with abstract data types. We looked at the list, but let's look at an implementation of the list, something we call the stack. And I'd best like to look at the implementations of these things as an exercise with a real example. So we're going to show a real example. The concept of a stack is relatively straightforward. It's exactly what you would think it was. It's a stack. You push to the top, you pop from the top. We call it push and pop. And if you write functions to do it, you would write the function, call them push and pop. Now, there's quite a few applications of stacks in the computer science world. We're going to specifically look at the one which is the calculator. And of course, you use stacks all the time. If you use a computer, anytime you've used any computer programs are made up of function calls, and the function calls, when you call a function, you're putting it on the top of the stack. When the function is completed, it gets pulled off the stack. That way you can keep track of the way the function calls are being called in that order. But right now, let's look at a calculator. So a very, very basic stack computer, which we would do here for, let's say, the example of 1 plus 1. Let's first put the operations in an order that a computer can actually do the operations. So this is called Postfix. We're going to talk a little bit about that. But what we're going to do is we're going to change it to 1, 1, and plus. This is also called reverse Polish notation. If you've ever used an RPN calculator, you know that you don't do 1 plus 1, you do 1, 1, and then you apply the operator. So, and when you look at how this works with a stack, it's going to make perfect sense. So how does this actually work in the computer itself? Well, if the computer has a stack, it sees the first number, it pushes it to the stack, 1. Sees the second number, it pushes it to the stack. Now the stack has a 1 and a 1 on top of it. When it sees an operator, it's going to pop the two numbers, which basically pulls the one off, pulls the other one off, and then it's going to do the operation, which in this case is addition, and the result of that operation is going to be pushed back to the stack. So when you used to have a 1 and a 1 on the stack, when you do the operation addition, the result being pushed back is the 2. That should make perfect sense. It's not really anything trickier than that. Now, if you look at this and how it works, and there's a little bit more complexity to it when you add things like parentheses and other things in, but the basic rules of operation, if you got a number, you push it to the stack. If you've got an operator, you pop the last two entries off the stack, you apply the operation, and you push the result back to the stack. That's it. It's a very simple conceptually way to do this. Okay, so how would you create some of these things in this case, we'll be dealing with JavaScript code, but let's assume that we've built a stack and the pop function returns the value of the top. So if you were to make a function called, let's say, multiply, then you would pop one number, you'd pop the other number, and you'd push back the product of the two, and that's it. That's it. Addition, subtraction, multiplication, division. Only difference is going to be the name of the function and what they do. So it's very easy to create functions that deal with the operations associated with the basic operations. It just really isn't that hard. So let's go to a little bit more complex example here. So in this case, I'm going to do 3 times 10 plus 5 quantity divided by 5. I'm going to assume that the rules of precedence here are the 10 and the 5 get added and divided by the 5, and then that gets multiplied by the 3. But if you know anything about the arithmetic involved, whether the 3 multiplication goes first or the divided by 5 goes first, it won't make any difference. But what's in the parentheses is going to take precedence here. If you were to convert that to postfix notation, that would make the actual order of the operations to be 10, 5 plus, 5 divide 3 times. Pretty straightforward here. And the automation of different forms of an equation to postfix notation is a different exercise, but there are algorithms that do that also. So how do you take a string and convert that string to a postfix notation that you can now implement as part of a stack? That's something that you can actually research and do. So those different methods of relating expressions, and in this case, these are both equivalent. These are both methods of relating an algebraic expression. Now, In the implementation of the stack computer, you push the 10, you push the 5. When the plus operator comes up, you pop both and you add them and you get a 15. 15 gets pushed back to the stack. You push the 5 to the stack. You put the divide, which will now be 15 divided by 5, which gives you 3. Then the 3 goes back to the stack. The other 3 goes to the stack. The multiplication comes up and you get your final result, which is a 9. That's it. That is a stack computer. What you will be required to do in data structures is to implement this in code and do a demonstration of how it works. So hopefully this is good for understanding the concept of a stack computer and will get you through the things you need to do for the implementation of one. Thank you very much and good programming.